We have to use the Pythagorean theorem to do some of these problems with coordinates that are geometry type problems. One of the things you need to know for some of these, though, are what these different quadrilaterals are. All right, so what do you know about a square? 4 equal sides. Four corners. All of these are quadrilaterals. They all have 4 corners. 4 right angles. All right, so a square, we got 90 degrees. I'm just going to use like A's and B's for the side lengths, okay? So for a square, we got, well, there we go. Maybe not. Well, we got all A's for the sides. All the sides are going to be the same. I don't know why it won't let me write. There we go. All right, so all 4 sides same, 90-degree angles. All right, what about a rectangle? Rectangle, we got A, B, why won't it let me write on it? All right, so you know what? We're going to get rid of those squares so I can write better. So it goes A, maybe not. Well, it goes AB, AB, sides alternate, length and width are going to be matching pairs, but they'll be different on depending on which side. What else about a rectangle? Rectangles also have 90-degree angles. All right, we got right angles on rectangles. All right, what about a rhombus? What are the sides like on a rhombus? A rhombus is all the same. A rhombus is basically a square in terms of the side lengths, but it is not 90 degrees. So they won't have right angles in their corners. What about a parallelogram? Parallelograms, they have the side lengths alternate. So they're going AB, AB. The opposite sides are the same. And it is also not 90 degrees. So a parallelogram is basically like a rectangle when you don't have 90-degree corners. A rhombus is basically like a square without the 90-degree corners. All right, so rhombus, all the same. Parallelogram, alternating sides. All 4 of these, first 4 here, they have where the opposite sides are parallel to each other. So even the rhombus and the parallelogram, the opposite sides are parallel, they're just not at 90-degree angles. On a square and rectangle, it's the same idea. Opposite sides are parallel, but they make the 90-degree angles. What about a kite? What's a kite look like? So it's like a diamond-ish shape. The difference between like a kite and just a diamond, usually the one side's going to be longer than the other side. So what you see with your side patterns on this is you'll see A, B, B. So the 2 matches as you go around, like this side and this side match, and then the bottom 2 will match. That one, angles could be basically anything. Usually you won't see 90 degrees, but you could have at least a 90-degree angle somewhere in there, or you could have no 90 degrees. What about a trapezoid? So a trapezoid, do any of the sides have to match? No. What you have is one pair of parallel sides. All right, so what that means, there's different ways a trapezoid can kind of look. You can have, that's a poor picture. This one should have been a little more angled, but you have a side like one that looks like that, where it's basically like a right triangle with one of the corners cut off, or you can have the ones that look kind of like that, which again, they're basically like a triangle with one of the corners cut off. All right. On both of those, the way I drew them, the top and bottom sides are the parallel sides. On this one on the right, those two on the sides, those are equal, but they don't have to be. On this one, they definitely are not. All right, so you can't tell much by the side lengths necessarily. So if you have different side lengths, like 3 or 4 different side lengths, that means it's probably going to be a trapezoid. With all of these others, generally you just have 2 kind of lengths to them. All right, so the way that works then, they give you ordered pairs. And we got to figure out what the shape is. So, this isn't anything that's necessarily horrible to do. It can be sometimes a little bit tricky. What we need to do is we got a rectangle. Like we said, that's 2 different side lengths. Rhombus, all the side lengths are the same, not 90-degree angles. Square, all the side lengths are the same, 90-degree angles. Trapezoid, that's where we got differences, okay? So as we go, we're gonna look at side lengths. So for that first side, what I'm doing is I got my square root of my change in x plus my change in y. All right, so they both happen to be 2. That's the first side. For my second side, looking there, I got the square root of 2 squared plus 2 squared. Already automatically not going to be a rectangle. If it was a rectangle, it would alternate as I go. Could still be a trapezoid because sometimes on those, you get like I said, the sides like that. These 2 sides could possibly be the same. So when we go to the third side, we're going from there to there. Squared plus 2 squared in our square root. And then we go from the last point back to the first one. We got 2 squared plus 2 squared in our square root. So that means all our side lengths are the same. We're looking at either a rhombus or a square. What's the difference between the 2? Squares have 90-degree angles. So we got to find the slopes. 90-degree angles are perpendicular lines. So if you remember back from earlier in the year, when we have perpendicular slopes, you flip it and change the sign. So when I do the slope for my first set of points, it's change in y over change in x. So I got 2 over 2. Both those were going up, both those are positive. That makes a 1. To go from my second to my third point, this time my change in y is going up, my change in x is going down. That makes it -1. What that means then, I got a square. That makes a right angle. So not a rhombus. If you take 1 is 1 over 1, flip it, change the sign, you still got 1, but it just becomes a -1. Any questions on that? All right, y'all give this one a try. little different answer choices this time. We got a kite, a rhombus, square, or trapezoid. Rhombus is correct. All right, so from W to X, I've got square root of 1 squared plus 5 squared. From X to Y, I've got square root of 5 squared plus 1 squared. Y to Z, square root of 1 squared plus 5 squared. And then Z back to W. We got the square root of 5 squared plus 1 squared. All right. You realize I didn't actually figure out what the side lengths were, did I? I can tell by the numbers that we're adding up in those that those are the same. What the actual side lengths are don't really matter unless it asks you for like the perimeter or the area of the shape. All right, so we know those are all the same. That means kite, trapezoid, ruled out. So we got to check our slopes. For W to X, change in Y over change in X, that's going to be a slope of 1/5. All right, for X to Y, that's going to be a slope of 5 over 1, which is just 5. Did the slope flip? Yeah. Did it change signs though? No. So what that means is it's not 90 degrees. That's what makes it a rhombus. All right. For it to be a square, it would have had to be like 1/5 and -5 or -1/5 and 5. Everybody kind of following that? Any questions? Another option, if you make a table on Desmos, it can plot those points, and sometimes you can tell from the picture. Likewise, you could do that on graph paper. If it was on inactive on your EOC, if you make the points on a graph, tell, like if I take a square and I turn it at an angle, it's hard to tell if it's a 90-degree angle for sure or not. So that sometimes can be a little tricky, but you know that is an option as well. All right, this one, some of y'all had a hard time with yesterday. So we got triangle DEF on the coordinate plane. Its vertices are located at those points. We need the area of the triangle. So first thing, area of a triangle. That is our base times height divided by 2, or 1/2 base times height, all the same. Base and height have to make 90-degree angles. Okay? The base and the height make a 90-degree angle. What we have, one of these makes a nice flat line. the x values are the same. Since the x values are the same, that means if I were to graph this, I'm going to have something that looks kind of like that on the line. So that's going to be my base. Okay? So from the -3's don't matter if I'm finding the length on that. So I'm just looking from 5 to -2. 5 to -2 is how far? 7. Okay? Everybody go with that part. We got a match. The x's match, so we find the distance on the y values. Our other point is at 3, 0. Well, I kind of drew this backwards. It would go this way. All right, so if we put a point there, what we're looking at to get the height is the distance apart they're going, right? You know, we got some diagonal sides. Those diagonal sides don't really matter. So what we're looking for the height is we had 2 that were the same, and we have a third thing. So the third thing is what's going to be different. So if I've got my -3's there, we're looking at how far apart that 3 is. So from -3 to 3 is how far? 6. So that makes my height 6. So I've got, well, I don't know what 6 times 7 is 42. 42 divided by 2 makes 21. Any questions on that one? I saw a decent amount of y'all miss that yesterday while I was out. But that's kind of how that works. You got one side that's going to be flat. That's going to be your base. Then you just have to find out how far away the other point is. And the distance the other point is away, like even if I turn it sideways, you take the one that, the same letter as the 2 that matched. So the 2 x's matched for the base. That means I got to find how far away the x value is. If the 2 y values match, then I was look for the y value. Make sense? What do I have to do on this one if I want to find the perimeter? Add all the sides. So we got to find all the sides. So the way we find all the sides is we're making a bunch of triangles. All right, so with each one of these triangles, we're doing Pythagorean theorem. So I got 5 and 5 there. I've got 5 and 11 there. 2 and 2 there. 8 and 8 there. All right, so each one of those we do Pythagorean theorem, like square root of 5 squared plus 5 squared. That's going to give me that side. Square root of 5 squared plus 11 squared, going to give me that side. Square root of 2 squared plus 2 squared gives me that side. Square root of 8 squared plus 8 squared is giving me that side. You get all those, you just add them together. Okay? With math 1, usually it's going to be like a triangle, but sometimes you see quadrilaterals on those. And you have to do that a decent amount where you have to do Pythagorean theorem multiple times. What about one like this? We're looking for the 4th point. Y'all actually did ones like this in 6th grade. We did them a little bit differently in 6th grade though. Okay, in 6th grade we were looking for matches because they would make like, there would be horizontal and vertical sides. So what we're looking for is like distances this time. Remember on a rectangle, our distances alternate, right? So right there, I've got 5 and 3 as my legs. All right, so for this next one, I've got 2 and 2 as my legs. What's the next one have to be? 5 and 3. So we're looking for something 5 and 3 away from those numbers, okay? So if I look at the x values, 5 away could be 4, could be -6. 3 away could be 2, could be -4. So just right there, I eliminated 2 of them, right? All right, so for these first 2, I did 5 away. That means the other one would have to be 1. Hey, look, that's D. Or it could be -7. For the second one, since I did 3 away for the x's, I got to do 5 away for the y values. So those are the 4 possible points we could really use on this, just by looking at the distances. So, like I said, that gives us D as the correct answer. Not everything kind of matches up. Again, you could put 3 points into Desmos. It'll graph them for you. And then you got to try to use that to figure out where the 4th point could go. If you do that, I would just add each one of these onto the table one at a time to see which one makes it look like a rectangle.